All right. Hi. Good morning, everybody. My name is Dr. Crystal Booty. I am retired Army, retired business owner. I am a research director for the University of Central Florida, and I manage the Tech Grove here at UCF Research Foundation. Just going to go through a brief presentation to introduce you to Team Orlando and the Tech Grove for those of you that don't know who we are. Welcome to the Tech Grove Connect webinar. We do these every month in partnership with the National Training and Simulation Association, NTSA. And for those of you that don't know, Team Orlando is a community here that is anchored by the 4 branches of the military that you can see at the top of the slide. So you have PEO STRI, which is Army, PM TRACES, which is Marine Corps, NOC-TSD, which is Navy, and AFMS, which is Air Force. And then under that, you can see the logos of all of the other agencies that make up Team Orlando. The defense side of things, which is the Department of Defense, brings in these 4 branches of service. We are multi-service funded. We're probably the only DoD Innovation Center that is funded by all 4 branches. Oh, that went too fast, sorry. The other agencies that are here with us are shown. So we have STTC, which is a member of the Tech Grove. ADL is a member of the Tech Grove. DHA, STE, TRADOC through Futures Command, which is where the STE kind of comes in, and the Central Florida Tech Bridge through Naval X and O&R of the Navy. So those are all of our paying members that make up the Tech Grove. The Research Park facility or area that you see has our facility in the bottom right, Partnership 4. That's where the Tech Grove is located. You have the DeFlores building, which is 2 above that. That is the Navy base. That's where NOC-TSD command is headquartered. And then you can kind of see all of the partnership buildings that are UCF buildings, but are leased out and operated by the various branches of the Department of Defense. So we are all located here in Orlando, in Research Park, just off the University of Central Florida main campus. The collaboration and outreach that we have that are a part of our service here to try to bring academia and industry and government together are TSIS, the PULSE, the Acquisition Process Exchange, ITSEC, which is our largest conference every year. And then we have Innovation Harvest Days here at Tech Grove. So we have Harvest Days and marketplaces, which kind of bring our innovators, non-traditional small businesses into the Tech Grove so that they can showcase their capabilities to government and other large industry partners to try to increase the defense industry base, which is one of our missions here at Tech Grove, is to increase the defense industry base. And here is the Tech Grove. So we are an innovation partnership. So it's a real partnership. It is PIA, which is a partnership intermediary agreement, which goes between UCF Research Foundation and NOC-TSD, and then all of the other branches or agencies that you see listed at the bottom here all contribute Navy and then fund us through the Navy. These are our pillars, if you will, that we operate within. So human performance is our overarching theme. So we try to increase human performance with modeling, training, and simulation. The ways that we try to do that are through AI, the augmented reality, and the LVC. So what we did with this slide is we tried to create a way that we can communicate what these mean to the industry partners and make it sound less DoD. Then at the bottom, we tried to add all of the, call it discipline areas that feed into these pillars. So this way, research professionals and industry can kind of relate and understand where their companies would fit into our mission and model. And speaking of our mission, so our 3 mission deliverables that we're targeted with are the defense industry base. So the defense industry base has been declining in the past, and we are trying to increase it. So we do that through transfer of technology, which could be through SBIRs, could be through OTAs, mostly non-FAR, vehicles that are allowing the industry and academia partners to work with the government. And in doing that, we're trying to find solutions to their problems through innovation, collaboration, and acceleration. These are the ways that you can engage with us. You can go to our website. On our website, centralfloridatechgrove.org. There's a contact us. You can fill out the form. You'll get email notifications that'll let you know when these types of events are happening. That's the only thing we send out through email, is just communication of when these events would be happening. The majority of them are hybrid, so you can attend them from anywhere. You don't necessarily have to physically come to the Tech Grove. But these are the way that we are able to create the community that will hopefully filter into increasing the DIB, transferring the technology, and solving the problems. Here's an example of some of the things. If you go to our events tab on our website, you'll see the PDF that shows the things that are happening in April or the next months coming up. We also have a 3-month planner that we put up. The most recent event coming next week is our Juice Bar. We have a F-35 training simulator here in Tech Grove, and the AFMS team, the Air Force Modeling and Simulation team, is going to be going through where the opportunities are for industry and academia to engage with them to help as they further develop the flight simulators for the F-35. Next week, we also have the Florida Interactive Entertainment Academy Game Lab demo. So that's going to be held here at the Tech Grove, where they will be showcasing all of their, final presentations and projects. And then if you wanted to snap a QR code, you could. If not, you're welcome to go to our website and become an Alliance member. We have a name for our community, the Growers Alliance, so you're welcome to go and become a part of our Alliance community and come support us at our events here that will hopefully lead to new innovation. So with that said, I will get into why we're here. So we are here to showcase a paper from ITSEC, and the team behind the paper are these 2 ladies here that I will introduce. The paper was a design of a novel system intersecting human factors, cognitive modeling, and recommendation of AI to explore approaches for collaborative human-AI teaming. So we have Dr. Summer Rabensky. She's a scientist at Aptima. She has expertise focusing on human performance, cognition, and training in emerging systems. In her role at Aptima, she serves as the capability lead for Air Force training, learning, and readiness technologies. Joining her, we have Dr. Maria Chaparro Osman. She is an associate scientist at Aptima. She has a background in decision-making under novel conditions, training and instructional design, performer-learner engagement during complex monitoring tasks in operational and training context, as well as usability of mobile and web-based applications. With that being said, welcome. Thank you for being here, and we look forward to hearing your exciting work.
Awesome. Thank you so much for the introduction. Myself and Maria are here presenting on behalf of the broader team, but I do want to recognize that we had a lot of other co-authors on that ITSEC paper. including our engineering and research support team, as well as our partners at Carnegie Mellon University. And so there's going to be a lot more detail in the paper. I do highly encourage folks go and read that. But what we're going to do today is cover a little bit of those, the goals of the paper and a broader stroke, and kind of treat this as a more open discussion. I'll be doing a good portion of the presentation. Maria will present on a few different slides, but she'll also be looking at the Q&A. So if you guys have any clarifying questions on any of the content that I go over, feel free to put those in the Q&A. And we'll also have time for open discussion as well. So to jump right into it, I don't think I have to tell a lot of people AI has been growing, especially in 2024, folks are seeing how they can use it in their daily lives. When we think about older forms of AI that use data-driven support models like GPS or search engines that were able to help us filter through a lot of different data, a lot of different ways to make decisions, and really trying to optimize those. Well, now AI can scale to really help us perform better within these highly data-rich environments and these highly risky, time-sensitive scenarios. So when we talk about the DoD community, how can AI help in the mission? How can it help us find the right kind of information that we're looking for, allow us to gain situational awareness more quickly, and make more effective decisions? But obviously, there's a lot of risk if we lean on our AI solutions in order to make decisions. So what we really need to do is make sure that we have an appropriate level of trust within the AI in terms of what it can and can't do. One of those environments that makes a ton of sense is joint all-domain command and control. If it wasn't already difficult enough to maintain awareness of all the systems within your own service, but now having this large interconnected web of all of these different platforms, information types, and trying to paint this larger war picture, we're going to have to rely on analysis techniques, decision making, and sense making in that. So as we try to grow AI within these data-rich environments, how do we ensure that we have trust? Now, a lot of folks define trust in different ways, so I'd like to make the distinction, at least for the rest of this presentation, that there's usually two different kinds of trust. There's competency-related trust, so I have faith that the AI can do the task that I've given it to do. So for example, I trust that a contractor can do work within my home, but I may not trust my partner to do the same thing. In the same boat, you have sort of this affective trust, sort of more of that trust fall level that I believe it has the best intentions for me and that I am putting my faith within that system. For this effort, what we wanted to focus on was competency related trust. How do we make sure that it's calibrated in terms of where someone should put trust in AI to handle a task and where should it not? How can we ensure that they have the appropriate mental model of team roles and then they can lean on their AI team member? And so when we talk about trust, there's the concept of under trust. So someone believes that the AI is not capable when it may be fully capable of handling certain tasks. And then we have overtrust, where you believe it can do more than it was intended to do. There are probably a lot of folks here that have tried out ChatGPT. Some folks may believe or have overtrust where they believe ChatGPT is flawless and the information that it gives doesn't have any errors. And in the same sense, we have undertrust where folks that are using ChatGPT may continue to scrutinize it and constantly verify the information that it gives, which ends up being slower than probably doing it independently. So what are some of the things that happen when trust is too high? A lot of the literature out there before we started in this effort looks at overconfidence or misuse. You start putting more faith into the system than you traditionally would, and you start disregarding red flags. So again, when AI starts to make a mistake, you stop looking, you stop supervising or paying attention to what the AI is doing, and you start to become somewhat complacent. Some of the causes that we see within literature is when a system doesn't provide transparency in terms of how it's doing things or how confident it is in certain aspects. Someone who misunderstands agent capabilities. Within high-risk scenarios with high pressures, people may decide to put their faith within those systems. And folks individually have their own biases or their own positivity where they just have a higher propensity to trust systems altogether. Again, some of those negative impacts of that tend to be inappropriately assessing how much risk there is, taking AI's recommendations with faith, as well as potential safety breaches. I'm sure everyone here has probably heard in the past year of someone putting something in the chat GPT that they probably shouldn't have. So knowing when they can trust, what kind of information they can trust to put within those systems. So what about when trust is too low? What we end up seeing is that, again, people inappropriately use AI. So they start engaging in behaviors where they're deciding to fact check everything or digging into areas of an AI or an interface that isn't necessary for the task. They may even start to discontinue use of AI. So a lot of our DoD partners on here are likely looking to or already funding the development of these highly complex AI models and interfaces and analytics. Well, if we were to invest all this time and then it ends up going into the hands of the warfighter and misunderstandings lead to folks discontinuing use of these solutions that so much investments was put into, that's also a loss from the perspective of where we put the innovations simply for them not to be used at the mission edge. So again, causes for this end up being AI mistakes or failures, misunderstandings of agent capabilities, as well as limited experience with AI. Folks are getting more and more exposure to it, so some of those causes can start to become less prominent. But what we see with when trust is too low is degraded human performance. Again, constantly fact checking their AI teammates, micromanaging like we would do with human teams, as well as frustration. And again, those wasted costs if we develop these solutions that ultimately don't get used by the warfighter. So how do we ensure we have calibrated trust? One way when we talk about competency related trust that I believe that the agent can do what I have given it to do. We want to make sure that there's alignment between the goals. I know what I'm going to do and the AI knows what it should do and where our lanes are and where we collaborate. That we have a shared mental model of what the goal is and the priorities. That the agent and the human both set up the right expectations for who's doing what, and that they have similar decision strategies. When we talk about human teams, we often infer we may have explicit strategies that we use to identify goals and team roles and strategies. And sometimes they're also implicit, but within all kinds of teams, we end up having discourse. I thought I was going to send this email. I thought you were handling that task. And we have challenges between those two. So how can we build a naturalistic way for AI to calibrate trust or calibrate those mental models in the same way that human teams do? And that was sort of the goal of this effort. First, I'm going to pass it over to Maria in terms of how we actually go about measuring trust and what we could pull in here throughout a dynamic interface.
Thanks, Summer. So this is personally my favorite bit. But so I want to cover some of the benefits and limitations associated with the ways that you can actually measure trust. Traditionally, trust has been measured using self-report measures like the trust in automated systems, pretty common trust scale. And so there's benefits of using these types of self-report measures. So a lot of them are validated, they're reliable, they can allow you to target aspects of trust like reliance, and they're very difficult to administer. And so it makes them a great option to measure trust. But there are some drawbacks. So it's not always feasible to administer a survey or have an additional bit of survey software there. And you don't always want to detract from the main mission of actually using the system. They also, so the fact that it can target aspects of trust is great, but it also limits you, right? So you might need to use multiple skills to get at the full breadth of trust that you need. So another measure type is physiological measures. And so we have a good chunk here of measures, but I'll just focus on a few. So eye tracking, you can look at how long a user is spending viewing certain information. And then with heart rate variability, you can, I'll say with heart rate variability, higher variability corresponds with deeper levels of trust. But these measures are also limited in how they can be used. So it's not always feasible to transport physiological tools, and it's not always easy to integrate them into a system. They typically require Bluetooth, and that's not allowed in classified spaces, so they're limited in that way. And sensors like EEG can take lots of time to calibrate. They're also pretty costly. And so that brings us to this last type of measure, which is behavioral. And typically, if you know trust pretty well, you think of use, disuse, abuse, and misuse of automation. You can also look at more granular behaviors. So whether you exit a system to verify information and you turn features on or off within the system. But overall behaviors are useful, they're data rich, and they're a meaningful source of information. They're also integrated into the system, right? So it's easier to get that type of information. One of the drawbacks here is that it can be difficult to make inferences just based on those behaviors. So a good example is that if you're focused on how much time someone is spending on a page and looking at information, it's difficult to say that that is because they are really trusting the system, they're super interested in it. It might just be that they're trying to look for more information on why they received the information that they did and learn a little bit more about the system. So the overall big takeaway I want to give here is that these measures really shine when they're used in conjunction with one another, which is what we did. And I will send it back over to Summer so you can kind of go through that.
Cool. So what we did as part of this effort is took a cognitive augmentation platform that we have called Alfred the Butler. So he is a support tool that provides analysts with real-time document suggestions for intelligence analysts that are trying to answer what are called priority intelligence requirements. This was a platform that we had developed on a previous SIBR effort as part of our cognitive augmentation capability, in which we have a bunch of different ISR and cognitive decision-making interfaces that we're able to leverage. So we have different ones that look at providing recommendations for mission planning, sorting through publicly available information, reviewing AI-generated photos, and correcting different tags. We have a variety of different platforms. What we used for this one, for Alfred the Butler as one of our cognitive assistants, we wanted to make sure that we eliminated as many other variables that folks may consider of whether or not they trust the system as possible. Alfred the Butler scrapes publicly available information in articles for someone who may be trying to see the state of an adversary based off of different news outlets. This allowed us a platform that was very agnostic in terms of there wasn't a lot of pictures or different formatting or different graphical aspects that might lead someone to trust something because it looks more polished. So it really rid of a lot of these extraneous variables that we were interested in looking into. So as part of, as you're going through doing research or reviewing different news articles, you have factors that you consider on how much you trust that information, especially in 2024 when we talk about misinformation. Everyone has factors that they consider when reviewing information on whether or not they trust what they're reading and whether or not they trust a recommendation. So for example, everyone has different factors they consider when buying a car. Some folks may put higher value on the safety of the car or how cheap it is, while other folks may put more emphasis on the features that the car has or the color. But everyone rates these factors differently. So how can an AI in a decision-making sense engage with the individual and understand what they're looking for and align with their mental model of their goals? One may say that you could just ask someone simply their decision-making factors at the beginning, but often when we go in these information-rich environments where we may be unfamiliar, the search often changes as we go along. We're dynamic, we may identify, okay, this one is outside of my scope, and the decision criteria change. So then again, as a human team, how can we identify the points of highest value with minimal interruption to make those interventions? So we identified and built this sort of concept around it. First, whenever you're making any sort of decision, you have attributes that you consider in that decision. For example, if you're going to drive to a restaurant and you enter a route into Google Maps, you'll see the different routes that come up. You may look at it and say, oh no, I don't like driving down that road. The roads are really narrow, or there's construction over on this other route, and you have those factors you consider. Similarly, when reviewing an article, you may look at things like the title, the source that it's coming from, or how recent the article was. Then when engaging with a system, you monitor those different criteria as you go along. What you do is you might go within Google Maps and say, I'd like to avoid tolls, or I want to avoid highways. And then you're able to, the Google Maps AI will then update those routes. So when we talk about whether or not those article recommendations are good, we may query the user for one that they rejected and ask them specifically why. So what were some of the criteria that they decided whether or not to accept or reject it? And then we would augment. What we might do in the case of Google Maps, it then presents you with new routes. But as we talk about information, decision making, it might, the agent can, or the AI can provide you some insights into why it recommended it, how you can, as the user, improve the recommendations that you're getting, and update its own recommendation AI algorithms. So what we did first as part of this effort is actually had someone interact with Alfred as it was. What they did was go through all the different screens and recommendations through Alfred and did a think aloud. Within this context, doing a similar sort of cognitive walkthrough with any kind of system could help you to identify what are factors that people consider in their decision making, and what kinds of information are people looking for as they engage with the new system. Through that, what we were able to identify is 7 different factors that folks look for. There's sort of the top level information that occurs when someone is looking at a particular article recommendation, and then there are factors that they consider that are relative to that specific question that they're trying to answer. So things like how recent the article was, the title, where the article is from, and where the author are kind of more rigid attributes that people consider in their decision making. Even as they go to answer different questions, people have biases that they apply to each of these. On the other hand, there's relative ones saying this is my current goal and this is what I'm looking for. How well do these recommendations align to the goal at that moment in time? Again, which can be dynamic as you find out more information. As a result of some of these aspects that folks are looking for, these are not only areas in which an AI can build a model of the user's individual decision factor ratings, but it's also an opportunity to try and provide transparency into these factors at the right time. I really like the way that the trust literature has been moving and the way that we talk about transparency now. If we've provided transparency on everything all the time, it doesn't necessarily mean that leads to more trust. And a lot of times it might actually put extra cognitive workload burden on the operator. If we give an AI confidence score on every single message, how much does that really help them to understand what's happening? What we really want to do is offer translucency. When someone is conflicted with a goal or conflicted with a recommendation, we want to make sure we're providing the insights into the right kinds of information that help them determine whether or not to use that recommendation at the right time. So what that meant is we looked out into the how the commercial sectors are trying to get feedback that can for systems that we could mimic within this ISR intelligence analyst scenario. So what you see for that left picture was how we updated a cognitive model related to the decision-making factors that people considered. So for example, here, if someone rejected an article, they could tell the system why, including whether or not they found the title relevant, the content irrelevant, whether they found the author untrustworthy, as well as an open field so that we could identify if there were other decision-making criteria that weren't represented there. Additionally, if someone accepted an article and they said, yes, this is exactly what I'm looking for, how do I get more recommendations like this? They could get an insight into what were some of the keywords that Alfred was considering, and then what they could also add in order to get more recommendations like that. Both of these allow decision-making criteria to change over time as we see behaviors change. So then we wanted to understand what might be good times where someone can, where a system can intervene. How would we know that this is the right time to ask them for feedback so that we can minimize the amount of times that there are interruptions to the mission? So what we did was we provided them both a smart and a stupid version of Alfred. We called those the incompetent and the competent to see if there were any behaviors that might be indicative of distrust in the system. So we saw some interesting trends here. For example, in debriefs, people noted that they spent less time reviewing the articles in the incompetent condition. They found that they were uh, uh, seeing no use in actually opening up each article and reading every word. So they weren't seeing it as a valuable investment of their time. So they spent less and less time reviewing Alfred's recommendations. They were also more likely, obviously, to reject those recommended articles. And they also started to turn off different functionality within Alfred, as they found if it wasn't giving me relevant information, it was simply detracting me from my goal of doing it by myself. They were also refreshing the system more frequently in an attempt to find more relevant recommendations. What we found on the competent perspective is that folks were less likely to drill down and accept Alfred's recommendations at face value. The interesting part about that is that we saw the same thing in the incompetent condition, is that folks were more likely to reject articles at that face value and they spent less time reviewing. So there's sort of this trust forming stage where people are likely to investigate a little bit more, and then they sort of set their trust values and move from there. And so they'll either start to put faith in it or stop putting faith in it. And what we also found is that they were less likely to select or go into articles. And if they did open an article, they spent more time reading it because they were seeing the value in those recommendations. So this gave us some insight into some behaviors that could be tracked by a cognitive model to see if there are behaviors change over time as they're interacting with articles. So for example, if we see that a recommendation was given and from a certain source with particular keywords in it, and people didn't open up the article and they accepted it. That means when presented with another article that had very similar characteristics, we would anticipate them to accept it at the face value. But what if the behaviors of how they're interacting with the system change? It's an opportunity to understand there might be something different about this article that the human is considering that the AI could also start to consider. And so was our approach for determining when interventions may make sense. So to put that in additional context, what we did was we worked with Carnegie Mellon University's dynamic decision-making lab, in which they created, using instance-based learning, a model representation of the human. So keep in mind the recommendation model that Alfred used in order to make recommended articles was separate from the one that made its own, separate from the cognitive model that made predictions about what behaviors they would take. This is something that we're really growing into at Aptima, is that there are so many different AI models out there, different recommendation models, different LLMs that all have different benefits and limitations. So it's through this multi-agent approach that we're able to leverage the benefits of each of those. So the one that made the recommendations and the one that predicted which ones users would like are two separate models. So with Carnegie Mellon's university's model, we were able to calculate the probability and confidence that someone would accept, reject, or ignore an article. Any user feedback that they gave on different articles were given back to the IBL model, and then weight the factors of the article as well as the behaviors that they were doing and update those. So for example, if someone said that I found the title super relevant, and that was the main reason that I accepted it, the title of the article would be weighted more heavily in its predictions moving forward. So what does this mean in terms of when we intervened? What that means is that we weren't a boy cried wolf scenario where we asked everyone on every single article, hey, did you like that and why? Because again, we want to make sure that we're not detracting from the mission. We only want to intervene when it makes sense. In the military, we do after action reviews after we after we perform a mission. And in our corporate teams, we have working meetings or powwows when we find that everyone isn't on the same page. So what that meant is that if the IBL model predicted that they would reject the article and they rejected it, no model calibration was needed. What that assumes is that the AI and the human are on the same page and we can keep going towards the mission. But if what the AI thought the user would do was different, then it's an opportunity for us to intervene. The AI can ask, hey, is there something here that you're considering that I wasn't considering? So we provided those sort of interventions to the users. We, when those mispredictions happened, it would intervene, it would ask them about the factors, and they were given different recommendations moving forward. So utilizing these aspects of analytical rigor that are used within the intelligence community, what we found is that they had higher confidence in the aspects that were within the model. So for example, providing a diverse set of resources that cover multiple perspectives. We were able to improve people's confidence that users' perspective that Alfred was competent in providing them a diverse set of resources, as well as assessing the relevancy of the recommended articles. This was not only through the interventions, but also through the transparency into the keywords that users were presented with. Now, some folks may ask, why are things like verifying the details of validity and accuracy lower, or understanding the stance that the source takes? Those were functionality that we didn't have within Alfred during that time that could be made transparent or could give the user insights into those. So those are areas in which we can provide additional AI that gives insight into those or to grow that. What we found in some of the debriefs with the different users that interacted with Alfred with the interventions is that they felt like it was a more proactive relationship, that Alfred was seeking to improve the recommendations it was giving to them. So where do we want to go from here? Within this effort, what we were able to find is that, one, we were able to, from an engineering perspective, create a dynamic trust calibration interface workflow. The goal was to build it in a way that it could be extensible to a variety of different computer workstation style tasks. So when we talk about remote piloting, we talk about a joint all-domain command and control, intelligence and analysis. All of those are going to require someone making interactions and diving into some of these elements. So some of you might say, well, if I have a novice, should the AI model really be calibrating to the decisions that they make? Who's to say that their decisions are good ones? Although that was the goal of this effort, is as we're still growing and AI still is maturing in terms of how often it makes mistakes, we wanted to make sure the agent can calibrate to the human. But there's also areas in which the same kind of framework could extend to things like training applications. So we can create, again, a similar model of what an expert would do, and then use those as times to intervene with a novice and provide them insights into other factors they should consider in their decision making. So as we talk about a proactive human agent team, how can they really work together and bolster each of their own decision making? I see that we have some different Q&A. So from this point, I think we can kind of do some of these open discussions. So if any folks have any questions, feel free to put those in.
There's still some questions in the chat. Sorry, I'm having some difficulty publishing responses.
No problem. So do you have controls for how you would define expert versus novice? So when we talk about the right kind of decisions that folks should make in the context of analytical rigor, there are certain metrics that are considered a marker of success. So for example, they need to make sure that they have, they're not going to just one source for their, all of their information. So in terms of an expert, they would look at various different sources. They would also make sure that they look at opposing viewpoints. So for example, if we were doing, we were looking at publicly available information to understand one adversary, we wouldn't only look at US published articles, we would also look at articles from other coalition partners or other adversaries to understand if there's competing messaging that's coming through, especially when we talk about misinformation. And so when we talk about making that sort of expert model in the intelligence community, it's really saying, what does the spread of information when someone is looking at a particular question, and modeling that, and then intervening to prompt the user, hey, it looks like most of the articles that you've been finding are speaking positively to this issue. Consider narrowing your search down to a negative aspect. Then when we talk about extending the same model to a training domain, it might mean that we take an expert decision framework in something like dynamic targeting. There might not always be a correct answer in terms of what resources to use, but there are some factors that experts in a particular mission may weight more heavily. So giving users insight into some decision criteria that would normally flag that as one answer is more right, and then intervening and reminding users about factors that they probably didn't consider in that use case. I'm looking through some of the Q&A. So how do you think users will calibrate the model of AI partners in warfighting systems, like heads-up displays or other JADC2 systems where job duties may not provide enough time, attention, cognitive resources to update the model while in contact? So at least through this effort, what we looked to do was to try and make sure it was part of their normal workflow. So in things like heads-up displays, there's the opportunity to leverage either some more of those physio markers or sort of voice commands. When we talk about JADC2 systems, the workflow can be designed in such a way that it's giving feedback to the user in ways that they're unaware of. So for example, what we did was we leveraged sort of the accepting or rejecting recommendations to provide feedback to the model in terms of what it was looking for. And then that could be provided to the recommendation AI to prioritize putting up different articles. If we talk about different JADC2 systems where someone is saying, oh, this is the asset that should deal with that target, and they're generating different resources that get passed to the next station. Identifying one of the main reasons why or a backup are ways to give implicit decision-making criteria. The system can track all those different criteria, and all it has to do is match it up to previous decisions that were made. Through our interface, we were able to change the weighting, but there's definitely, through longer tasks, ways to do that in an unobtrusive way. Next, we have a question. AI has become a buzz term. There is machine learning, which is a statistical model, while generative is about cognitive using large language models. Both require human to trust. Are you covering both types? What we wanted to do within this effort was look at an agnostic approach that was irrespective of the type of AI. Now, I will say in other efforts, there are ways that we are providing insight, both from statistical models. So for example, on one of our efforts, Semaphore, we're looking at how do you actually flag, create statistical models that can detect altered images. And so what we do there is give insight to the user, hey, we believe that this one was either fully generated or edited for these reasons, and give these tags as well as insights into how the statistical model came to that conclusion. When we talk generative and other approaches, like our Ready Relevant Learning Challenge, where we were the awardees of that challenge and generated an ISD support tool with Craft or with Nautical, what we did was actually prompt the large language model as to how it reached its solution. And when it generated ISD materials, put in comments that actually said why it made these decision criteria itself. And then within that provided feedback areas where it could be used to improve the model moving forward. So we are definitely under other efforts exploring how this sort of same trust framework can be applied to multiple different kinds of modeling through different web interface approaches. Next, we have, are we looking at the risk, probability of occurrence, and consequence as drivers for the degree of trust we require? So within this context of this effort, what we did was we picked a topic that the general public could understand, but definitely wouldn't be familiar with. So what we find with risk is that experts are less likely to lean on AI as they have their own decision-making model criteria. Whereas novices generally tend to put faith within AI because they're not entirely sure what they're doing. So in this context, what we did was they had to answer what are large-scale security measures that can be made for IoT cybersecurity, which a lot of experts or a lot of users who went through the interface knew nothing about. So they had to put some level of faith within Alfred and the recommendations it was giving. Risk is definitely one of those touchier subjects when we talk about humans and AI. So for example, let's say it's the Jetsons and you have a robot maid. I may trust it to bring in my mail for me, but I don't trust it to shave my legs. So when we talk about risk, it's definitely different in terms of the tasks that we give them. And giving insight and transparency into some of those are some of the leading methods for building trust with humans. Also, on that same note, it's making it very clear to the human what the AI can't do. So, for example, saying, I can't verify my own information. There's a good chunk of research out there right now that says that denial in the case of a trust violation is a perfectly valid trust calibration technique. So, for example, if you go into a system and it says, sorry, I can't do that, or that's not my job, that is a way to properly calibrate trust so that the human knows what to lean on the AI for. Next, we have, there are instances where people have a high trust in AI and AI-like environments like Alexa, secure retail websites, but later find out that their information was stolen or sold. Have you started looking into how trust varies across environments that work in this almost disjointed manner, where people maintain trust in these environments despite stolen data and continue to provide PPI to websites over time? A lot of the research shows that if you have alternatives, people will go to those. But if there are no alternate uh, resources that you can use, then people have to continue relying on it. So, for example, if someone's information was stolen from Amazon, yet there's no competitor out there that can get you packages as quickly, folks by default choose convenience over trust. Maria,
Yeah,
do you have anything?
I was going to add in seconding what Summer was saying. The other bit is just that convenience. So how difficult is using another system compared to this? So if it's going to take a lot of extra time to learn or it's extra steps, people will typically go with what they normally do. So convenience, I feel like, is key. That's what we typically see.
Yeah. Next, we have, in your opinion, how could artificial intelligence impact the development of modeling and simulation? What are the most frequent objections to AI adoption that you encounter? What human performance metrics are used to evaluate changing levels of trust? And how do you repair broken trust with that machine? There are different trust repair strategies that are out there. I alluded to a few of those beforehand. Feel free to reach out to one of these emails. I can point you to a few papers that talk about when the right repair strategies are appropriate. In terms of human performance metrics to evaluate changing levels of trust, we do also have a paper that was put in ModSim last year that talked all about the different ways to measure trust. And then in terms of objections to AI adoption that we encounter, a good part of it is individual propensity to trust, but then it is also still the same risk thing. If it's a low level risk task, hey, I'm writing up a summary of a topic, then you trust AI to at least do all the formatting and everything. But let's say you wanted to send an email to someone very important, then you may not trust that because you would be owning some of that risk. Next question was concerning the IBL model. How many participants had responded or taken part in the studies that the IBL model was based on? So we used a multifaceted approach. So to get at some of the issues that come with training up some of these modeling approaches. The IBL model that CMU used was one that could work off of smaller data sets. So we had some users go through, and then we also used a persona approach. So some of the team members played the roles of, as Maria had mentioned earlier, those that tend to misuse, disuse, abuse, so that the model could be fed the gamut of the kinds of users that might interact with that. Then there is also a pretty good paper that we put out for HFE in which we were speaking to some of these more novel approaches that's tangential to the ITSEC one of can we use user personas and actually generatively develop variants of those and use those personas to quickly train up models so that they can be tested within these environments. So when we talk about like digital twinning of human data, in order to rapidly stand up these sort of adaptive approaches within these environments. So a lot of these questions you guys have been putting out there, we are tackling as part of other efforts or separate from this paper. So by all means, please reach out. We are developing solutions to a lot of these different pain points. And then another question we have is, have you considered or used AI training agents to further improve the performance? I might need a little bit more definition there in terms of if you mean performance of the team or performance of the AI. So in some other approach, other efforts with training across the services, we're looking like at what I had mentioned previously, sort of these multi-agent approaches. When we talk about training or teaming, in order to fully leverage the benefits of all of the different kinds of analytics and AI, we put them in the appropriate spots. So for example, being able to summarize large pieces of data or sort of menial tasks, that's where some of these generative modeling approaches like LLMs make a lot of sense. But then also layering those on top of different AI that make the messaging more coherent or NLP to extract themes, and then running it through LLMs in order to put it in the layman's terms. So training up and using multiple agents are approaches that we're going after in order to make the human interaction with the AI as naturalistic as possible, while also improving mission performance, improving decision making, and keeping it efficient as possible. Let's see. Any other questions?
It doesn't look like it.
Alrighty.
All right. Well, thank you both for being here, and thank you for the discussion and the interaction and answering of questions. I think that we were talking before the webinar that the video will be published on the NTSA website under the prior events within 24 hours. So give it a day, and then the video will be available. I believe on the website is the paper. I tried to post it in the chat. It wouldn't post in the chat. So if we need to somehow get your paper out to people, we can try to send it out. But I really appreciate your time. Really appreciate the conversation, and hope everybody enjoyed it as well, and that everybody has a great rest of their day and great weekend. So thank you, everybody.
Awesome. Have a great day.
You too.